Hello everyone, welcome to MakeTube's channel, and in this video I'm going to explain about finding and locating the number of instantaneous centers as a part 2. Already the part 1 is explained in the previous video by taking a standard example. So here I'm going to take two more example in this part 2 video tutorial. So let us go to the second example. The second example I'm considering, which is a slider crank mechanism. So I'm going to consider a slider crank mechanism which can be shown like this on a 2D diagram. So total how many links it is having? One, two, three, four. Okay. So total four links are there. Here how the mechanism works means due to the rotation of the link 2, this link 4 will be sliding over the link 1. So that is only slider crank mechanism. And the application is the rotary motion can be converted into sliding motion, and the sliding motion can be converted into rotary motion, vice versa. For both application we can use this slider crank mechanism. So here, what is our requirement here? We need to find out number of instantaneous centers and we need to locate the number of instantaneous centers over the required diagram. So finding the number of instantaneous centers is with the help of number of links. So we know that number of links are given 4. Based upon this number of links, we can find out the number of instantaneous centers by the given standard formula capital N is equal to small n into n minus 1 by 2. Substitute the value 4, then you'll get the number of instantaneous centers as 6. So 6 instantaneous centers we need to locate on the given slider crank mechanism. Next, we go for drawing a simple tabular column which will represent all the instantaneous centers we need to locate on the given mechanism diagram. So we know that number of instantaneous centers are 6, and the tabular column can be taken like this. Number of links are 1, 2, 3, 4, and based upon that number of instantaneous centers are 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. So how to know these are the instantaneous centers means the analysis already I have explained in the previous video. If you want to go through it, again go through it, then you came to know how to represent all these instantaneous centers within the tabular column. Next, first we try to locate fixed and permanent instantaneous centers, and neither fixed nor permanent can be represented with the help of Arnold Kennedy's theorem. So first we try to locate I12, which is the instantaneous center in between one and two link. So joint in between one link and two link will give you the instantaneous center I12. So here you can locate I12. Next, similarly, so here I12 is over. I would like to strike off on the tabular column because we can confirm that it is completed. The location of this I12 is completed. Next, we go for locating I23, which is the joint in between 2 and 3 links. So this joint will become I23. So I23 is also over. Strike it off. Next, we try to locate I34, which is the joint in between 3. There is a connecting rod, and 4, which is the sliding member, the joining point, that is a joint, will give us I34. So I34 is also over. Strike it off. Next, we try to represent one more instantaneous center, which is with reference to the two links, that is link 4 and 1. So in between 1 and 4, there should be some instantaneous center. So that instantaneous center is actually I14, but here this I14 is located at an infinite location. So why? Because here we are finding the center point with respect to which this sliding member is going to move. So sliding member always moves in straight line location. So when you try to consider straight line, it doesn't have any uh, it, it doesn't have a particular instantaneous center. Means here the instantaneous center will be at an infinite location. How can you confirm that? Means try to imagine one object is moving over a circular path. Okay, so when the circle can be visible with our eyes, then we can say that the center point of rotation is at the center of the circular path. But when you keep on increasing the radius of the circular path, so what happens means here at one position, that means when the center becomes at an infinite location, so the object will appear like it is moving only in straight line. So that case only can be applied to the sliding member. So whenever the sliding member is there, its instantaneous center will be located at an infinite location. So that is why the I14, that means the center point in between 1 and 4 will be located at infinite location. So try off again in the tabular column I14 because I14 representation is also over. Next, remaining 1, 3 and 2, 4 are neither fixed nor permanent instantaneous centers. which can be located with the help of Arnold Kennedy's theorem. So remaining these I13, I23 can be represented by Kennedy's theorem. So for this Kennedy's theorem, first we need to draw a circle. So over the circle, we need to look at number of points. Those are should be equal to number of links. How many links are there? Four. So look at 4 points and give the names 1, 2, 3, 4. Then join all the points with straight line. So each and every straight line will represent, that is 1 to 2 line will represent here I12 point, and 2 to 3 line will represent I23 point, and 3 to 4 will represent I34, and 1 to 4 or 4 to 1 represents I1 for instantaneous center. So based upon these lines, we can represent remaining 1, 3 and 2, 4. So first we need to get I13. For getting I13, we need to join 1, 2, 3. So when you join 1, 2, 3, we can see two opposite triangles. Okay, here, and these two opposite triangles will make two straight lines by joining two instantaneous centers. So what are the instantaneous centers? Already I told you, 1 to 2 will give you I12, 2 to 3 will give you I23. So this I1 to I23 will give one straight line, and 3 4 I34 and I14 will give you another straight line. The intersecting point in between these two straight lines will be giving the required instantaneous center, that is I13. So I try to write that thing. For getting I13, we need to join two lines, that is I12 I23 and I14 I34. So now analyze over the diagram. I12 23. Where is I12? This is I12. Where is I23? This is I23. Okay, by joining these two and extend it. Okay, next I14 and I34. Where is I14? At an infinite location. Where is I34? Already joined to the I34. We need to join I14 to I34. Already joined these two lines. Okay, so intersecting point in between these two, I23 I12 and I34 I14, will give us the required instantaneous center, which is I13 here. So this intersecting point here becomes I13. Got it? So I13 is also over. Next we go for I24. For getting I24 over the circular diagram, we need to join 2 to 4. Join 2 to 4. Again we'll get two opposite triangles, from which we'll get two instantaneous centers, which will be making straight lines, and intersecting point in between those straight lines will be giving the required instantaneous center, that is I24. So try to represent. For getting I24, we need to join two lines, that is I12, I14 related to related to triangle 214. Next I23, I34 related to the opposite triangle 234. Okay, so in between these two lines, the intersecting point will give us the required I24 instantaneous center. So go for I12. Where is I12 here? This is I12. Next I14. Where is I14? At an infinite location. If you try to join I12 to I14, again from I12 you'll get one straight line or vertical line at an infinite location. So try to join and try to represent as I12 to I14. Next remaining I23, 34. Where is I23? This is I23. Where is I34? This is I34. So by joining these two and extending it, it should intersect I12 to I14. So when you extend it, it will intersect here. So this intersecting point will give us the required instantaneous center, which is of I24. Okay, so this is another example we can consider for locating the number of instantaneous centers. So for the slider crank mechanism, this is the way of representing the number of instantaneous center, finding and locating. So finally we have finished I13 and I24. So strike both of them. Then we can confirm that all the instantaneous centers are completed. That means representation or location is completed. And this strike of why I am giving means this will give you confirmation of which are the instantaneous centers are completed. So if you go for a very complicated mechanism, in that huge number of instantaneous centers will be there. So whatever the instantaneous center completed, if you strike it off, then you can see directly what are the remaining things are to be completed. So this kind of the method can be useful when there are more instantaneous centers are there, to avoid the confusion. So I hope you understood this simple example for finding and locating instantaneous center for slider crank mechanism. In the next video we'll take another complicate mechanism, and we try to find out and locate the instantaneous centers with the same analysis. So Up to now, that's it. And thanks for watching my video. And if you have not subscribed to my channel, please subscribe and follow my channel and suggest to your friends to subscribe my channel for more videos on the tutorials related to all mechanical engineering subjects. And once again, thank you all.